Good morning, students. How are you all? I think you are fine. You are preparing well for class 10 standard students. They all are understanding the concept. What it may be, I am going to explain on the board. You can understand. If you have doubt, you come to me and I will explain that all those things. What it may be your doubts. You have to come. You can come. I will explain here. So here, the second part of the science, I am going to explain to the second part, class 10, metals and non-metal. This is the second part I am going to explain. Now second part I am going to explain started. Now here, sodium and potassium are stored in kerosene oil. Why? So, because sodium and potassiums are more reactive in nature. Because they are more reactive in nature, if it is contact in air, it becomes explosive. If it is contact in air, it becomes explosive. It releases more heat. If it is contact in air, indirectly on the air, so it becomes as a heat. It becomes as more reactive, and it becomes as a more heat. And that purpose they will kept in kerosene. Understood? Some points are there. Are non-metals. Non-metals react with oxygen to form non-metal oxide. If non-metal oxide, example, and they are acidic in nature. These are non-metals I am saying. Understood? Non-metals are react with oxygen. When react with oxygen, then what it forms? It forms as a non-metal oxides. Non-metal oxide, and they are in nature. They are in acidic in nature. That is, blue litmus turns to red. Blue litmus paper, if you kept in that solution in that non-metallic oxide, if you kept in that, on that, people will get blue litmus paper is turned to their red litmus paper. Understood? And some non-metal oxides are neutral. Understood? So here examples: non-metallic oxide plus O2 oxides react with what? Non-metals plus non-metal oxide. What will be formed? Non-metal oxide. This is non-metal oxide will form. Understood? Or you can take sulfur plus O2 oxygen react with metallic. This metal sulfur is a metal, non-metallic oxide plus oxide. If you take, what will become? Sulfur dioxide. SO2 you will get. Right? And carbon is also non-metal and react with oxygen. Then what will form? CO2. That is formed as a carbon dioxide. Understood? Next I am going to explain the reaction with water. The second point of that is that means the reaction with water. First we are taken reaction with air. Now we are taking the reaction with water. What things will be there? Say, when metals react with water, form metal hydroxide and hydrogen gas is released. Metal hydroxide will form and hydrogen gas will be released from there. Understood? Evaporated. Some react with oil, cold water. Some metal react with cold water, and some metal react with hot water. Understood? Some metals react with hot water, and we can take. So example I will take here. See, metals react with hydrogen oxide. What we are taking? That is for hydroxide. And what we will get? That is for metal oxide. Metal hydroxide plus hydrogen gas will release. This is the arrow mark. This it will release from there. Metal hydroxide plus and hydrogen gas will be released. If you take sodium plus water, don't take H2O. This is H2. This is water. Don't get confusion. Understood? Metal hydroxide plus hydrogen gas will be liberated. And similarly, I will take here sodium plus H2O. What it will forms? NaOH will be. NaOH. That is for sodium hydroxide. Sodium plus hydroxide plus and hydrogen gas will will get. And similarly, calcium plus water we have to take. So what it will form? It gives calcium hydroxide, CaOH. Calcium hydroxide plus hydrogen gas will release from there outside. Some reactions with steam also. Steam, you know that already. And some do not react. Some metals does not react. So because I am going to that reason, non-metals do not react with water as to react that need to displace hydrogen. But hydrogen is replacing means how? If hydrogen is replacing from that reaction, we cannot get the solutions. And they need to donate electrons. Hydrogen electrons will donate. But if they did not donate the hydrogen ions, then how it forms the reactions of the product? That is for solution we will not get. And electrons of hydrogen, but it is not possible. They are themselves electrons acceptors. They are electrons acceptors are there. Accept means it will it will take the electrons. Next one is reaction with dilute acid. Third one is reaction with dilute acids. In the dilute acid, it has more water. In dilute acid having more water, maximum quantity will be there. Water will be, remember here. Metals react with acids to form respective salt and hydrogen. What it will form? Salt plus water, hydrogen gas. Salt plus hydrogen gas is released. Similarly, like that. This like that only. This is also salt and this is the hydrogen gas will release. So, if we take the example here, say zinc plus HCl, Zn, zinc plus hydrochloric acid. This is the acid content. This is acid, right? And what it will give? That is for zinc chloride will form, ZnCl will form, and hydrogen gas will release. Understood? Hydrogen gas will release. Understood? And metals below hydrogen reactivity series can't display hydrogen of acid. If you take in acids, if you take Zn plus H2SO4, Zn plus H2SO4, what it will give? It gives what it will give? Zinc plus sulfate will give. Zinc plus sulfate, SO4, and hydrogen gas will evaporate. Hydrogen gas will evaporate. Hydrogen gas will release from that, and the salt will lift here. Understood? So now you will explain non-metals. Non-metals do not react as they can't display hydrogen form from acid. It will not display. The hydrogen acid will be there. If hydrogen is there from that acid. Non-metals reason say, if non-metals do not react with the dilute acids, as to react they need to display the hydrogen. And for displacing they need to donate electrons. Similarly here also they need to donate electrons and hydrogen, but it is not possible. As they are themselves electrons are acceptors. Similarly like that only. This is water also and acid also. This will get same pattern on that. Understood? Now I am going to explain metallurgy, minerals, ores, gangue, various steps are involved in metallurgy. That is for concentration of ore. First one is various steps. First one I am going to explain this hydraulic washing. In that concentration of how their concentration of ore will separated. Hydraulic washing, magnetic separation, flotation process, and chemical separation. These are all I will explain. And after that I will explain second one I will explain, that is for oxidation. Right? So, say first one is metallurgy. What do you mean by metallurgy? It is the process of extraction of metal from its ore. Extraction means we will make separate that ores will make separate from that. So it is a process of extracting metals. Metals will make separate from the ore particle. Just you assume, if you take one magnet, if you throw it onto the mud, so mud, stone in that mud and all, in that soil and all, or in mud you throw, how they will attract the metal, that or the magnet, how they attract soil and all, how to make separate, we will take by hand directly, but here metals is separating by this process. Metal is separating by this process. We will take so many processes are there. We can separate by concentration of this is for concentration, we will separate. This is for hydraulic washing, and second one is magnetic separation and flotation process and chemical separation. These are the separation of we have to take of that particle, that is for metals we can take. So here what is in minerals? Minerals are, you know, that the element or compounds which occurring naturally in the earth crust. Right? Earth crust is present in that the upper layer of the earth. See, the upper layer, this having inside so many living structures. This is here, this is here, this is also here. This is the earth crust. This is the upper layer of the earth. Is called earth crust. We will get all those things in that. So that is minerals. Minerals, like just we are taking, that is called the elements or compounds which are occurring naturally in the earth crust is called minerals. Understood? Now ores. Now I am going to explain ore. Minerals that contain very high percentage of particles, metals. Maximum particles of metals are present in that, and the metal can be profitably extracting from it such that, or as minerals are called ores. We are taking the separate of the metals. We are making the separation that is nothing but that is we are getting for ores. And Gangwa is ores are usually contaminated with large amount of impurities. Some impurities are present in that in metals. So we will make separated out of them, such as soil, sand, etc. This and all present in that metals. So we will make separate into from the metals. That is nothing but that is for Gangwa. Now the various substeps are involved in metallurgy. That is for first one is that is for concentration of ore. In that we will make separation of the metal in this four process. First process, second process, third and fourth process will be there. We can take any process, we can make a concentration of ores. Now I am going to explain the first that is for concentration of ore. See, concentration of ore, it involves various methods like hydraulic washing machine and magnetic separation, flotation process and chemical separation. Understood? That is for concentration of ore. Now I am going to explain hydraulic washing machine. In this, the high speed of the stream of water is passed into the slope of and the ore is placed on it. It is a resultant of the heavier of the ore stay behind and lighter impurities flows then only with the stream of water. So I can take a funnel. See here, I will move the funnel, make it funnel, and that is for slope of that. This is the trough containing, this is for, and after that we have to take and make a funnel. This is connected to the tap. This is for water. Water is passing, and here is funnel. That is for crusted iron, crusted ore. We are putting into the funnel and it will passes into that. This is for stripping table, or you can take tube also, table, and this is a stand which is connected. Gangwa. Gangwa with water. With water. That is for ore. That is for gangwa with water. It is passed into that and it will come down. That is repeated. I will explain once again. In this, the high speed of a stream. The high speed of water is, and this is for crusted ore. Crusted means the small pieces of that crusted of ore, and it is passed in the steam water is passed through the slope. That is the slope which has ore placed on it, and as a result of the heavier ore stay behind. The heavier stay behind there only, and the lighter impurities will fall into that. Impurities flows along with a stream of water, along with a stream of flowing of water, and it will containing into that. That is what we are getting into that. This is the container. We are getting into that impurities of gangwa. Understood? Now here the limitations of this method is it is used for only for heavy ores like iron. Understood? Next one I am going to explain, that is for hydraulic washing is over. This is for first one over. That is for hydraulic washing. Now I am going to explain the magnetic separation. Magnetic separation. So magnetic separation, how it will come in? See here. This is two wheels and it is connected to the belt. This is the belt, leather belt, and it is connected to that coil. This is the wheels, and here these are the magnets, and we will take from that powdered ore from that funnel. From the tap, this is powdered ore, right? If you put onto that, drop onto the tap, this wheel will pass. This is the leather belt will rotate and it will come into that contact of, it will come down. Which are light particles, it will come inside, and heavy particles, that is for impurities, ore will contact with magnet, and maybe slowly they will come down in the another container. This is the another container. This is it come ore, and this is impurities. This will collect, and these are the ore particles will come inside, and the lighter particles it will go onto the belt. When belt is rotating, then suddenly it will come inside that. Suddenly the impurities, the light particles, the light impurities will come down, which will not contact with magnet. That impurities will come and down into that. This is the container, and another drop containing water, that is what the lighter, the magnetic affected, that slowly it will come down into the ore. Understood? These are ore. See, in this apparatus, we said is said as shown in the figure. The powdered ore is containing impurities as poured on slope of with the help of hooper. These are the two hoopers they are taken. As the leather belt revolves, it also revolves along as a result as ore falls later. Ores will fall later, but impurities will fall as soon. Letters, and it is being attached by the magnet, and impurities falls first. Impurities will fall first, but it will not contact to the magnet. It will not attack to the magnet. It will suddenly come and fall into that. Right? So impurities, the first they form as a different heaps. Hence they get separated. Ore will get separated, and impurities will get separated. Understood? And the limitations is it is used for ores only with magnet properties. It has magnet properties. Next I am going to explain the fourth flotation process. This is the fourth flotation process. So here what I will say. See here. In this, the apparatus it's set as shown in the figure. The powdered ore is containing impurities is poured in the tank. One we have to take tank 1 we can containing into the tank and make it separate. And this is a tube of the air condenser. This is connected to the water. This is the drop of we are taking that here also. Then the impurities will left here also, and this is the remaining part of that above on the it will. So here you see the powder of the containing impurities are poured into the tank containing pine oil and water. Now with the help of compressed air is passed. Compressed air is passed, and compressed air is passed. As a result of froth appears to which ore sticks as impurities and left behind down, that is for gangwa. We are getting into the down only bottom which is connected with the air. This is what we will get, that is for as the result of which sticks on the impurities will stick here, and what it will be the remaining down into that part is nothing but we are getting the separation of gangwa. Understood? That is for gangwa, that is for free ores. Understood? And limitation only used for sulfide ores as they have attraction towards pine oil or froth flotations. Understood? These are made separate into the container of that. This will remaining here at the top of that. These are the impurities, and inside that bottom of that is for gangwa. Using with pine oil. What we are using? Pine oil we will use, and it will oil we are using. Then to make a separate order into the container. Understood? This process now I am going to explain. That is for next chemical separation, or we can take Bayer's process. We can call it as Bayer's process or chemical separation. Listen. Now in the chemical separation, it is the method in which some chemical substance is added to the powder or containing impurities. As a result, that chemical substance only will react with ore but not with impurities. Okay, for example, I will tell here, I will take example. Now then, in the Bayer's process, ore plus chemical, what it forms? It gives as ore plus chemical, right? And plus impurities. If we add the chemicals here, it will give that is for ore plus chemical plus impurities. Impurities has been separated. Then after that we have to take this. We want to make ore also separation. If you take ore plus chemical, it gives ore is also separate plus and chemical also make separated. Ore is also made separated and chemical also made separated. If you take example here, bauxite ore, Al2O3, aluminum oxide plus, and that is for 2H2O plus sodium hydroxide. What it will form? Sodium plus aluminate it will form. Sodium aluminate plus, and hydrogen will make separate. Hydrogen also makes separate, and with that is for plus impurities. The remaining part will be there. The remaining rest of that oxide will be there. These impurities and these impurities will be separate. If you take this, what we will take this NaOH. This you can take this separated here. Again you make separate this. This will take water also remaining into the container of that in the upper of that, and this sodium aluminate will rest into the gangwa particles which is in the bottom of that. Understood? Now the second one I am going to explain, that is for oxidation of ore. Oxidation of ore. First one, which one we are done? First one we are done. That is for which one? Right. First one is concentration of ore. That has the fourth process. That is for hydraulic washing, magnetic suppression, froth flotation process and chemical suppression. Understood? Now I am going to explain the second one is oxidation of ore. Third one is reduction of ore. And fourth one is refining. Now I am going to explain only the second part, that is for oxidation of ore. What is given? It means converting concentration ore into metal oxide. What? Concentration of ore is converting into metal oxide. Did you understood? Now these steps, as these methods are involved, in this method also process we are getting to that. That is for first one is calcination. Calcination. And another one is, that is for roasting. Roasting. These two processes we will take. Now what is calcination? Calcination is the process of heating ore in absence of air. Calcination is what? In the absence of air, we will heat. That metal will heat in the absence of air, or absence of air, it gives metal oxide. In absence of air also it will give metal oxide. For example, if you take Zn, zinc plus CO3. If you heat in the absence of air, I will write here. Absence of air. What it will give? Zinc plus oxide will form. Zinc plus oxide will form, and CO2, carbon dioxide will get released. Carbon dioxide will be released. This is the ore we will get. Ore. This is the ore we will get separated. Zinc plus carbon dioxide if you take, if you heat in the absence of air, then we will get zinc oxide plus carbon dioxide. Similarly, you take CaCO3, calcium, in the heat, if you heat in the absence of air, what it will form? Calcium oxide will form. CaCO. Calcium oxide will form, and carbon dioxide will get released. Understood? This is the two of that calcination process will be then. That is for calcination is the process of ore which is absence of air. Now the roasting. What we will get? In presence of air. Heating of ore in presence of air. This is absence of air. This is absence of air. Absence of air. This is presence of air. What it is? Presence of air. This is absence of air, and this is presence of air. We are taking into that. This is what air. Ore is a heat, it gives metal oxide. If you heat, then also zinc oxide will give in the presence of, and sulfur dioxide will get. So if you take example here, say Zn plus SO, Zn. If you heat, what it will give? Zn oxide. If presence of air. Presence of air means oxygen will be there. You have to remember O2 will be there. Presence of air. Presence of air. Absence of air. Here presence of air. O2 will be there. What it will use? Zn ore. Zinc oxide will form, and sulfur dioxide. Here S left, here one left. SO2. This is what? That is for sulfur dioxide gas will release. The sulfur dioxide gas will release. This is the ore particles we will get from that. And next one is, we will take that reduction of metals we will explain in the next part. Understood?